am. So in 10 minutes, I'm going to present what is attempted here, which is what we have done the last 20 years. And I have not prepared PowerPoint presentations. Sometimes I don't, both because I didn't take the time, and because also sometimes PowerPoints put you in a mode that you're not spontaneous. And I would like to speak about the reason why we do these things that we have done and the way we have done them. And the key point about this report is that it is addressed to civil society and specifically to the NGO community. Our work is. And the question is, why? Why would one not address science to the world as a whole, but specifically to civil society? Well, the point is that when I started studying, or rather when I had completed my study, I had in my head a model whereas the scientists do research that goes to the manager, and the manager somehow implements that. There was no clear vision about who the manager was. I certainly didn't know any in Germany, and they were never clarified who they were. And somehow, also what was totally unclear was how they would actually get the information from us and use it. And this model continued to drive us, to drive my work, I guess, as I was employed in Indonesia for 2 years to spread the joys of trawling into Indonesia. And I discovered there that the manager was the bank, actually. It was the Asian Development Bank. I discovered later that it was the Asian Development Bank, which at the time was spreading millions and millions of loans to countries so they could buy trawlers. And they could buy trawlers to exploit the fish that was found in surveys, and they really estimated how much a trawler catches a year, say 10,000 tons, and they divided that 10,000 tons into the survey we estimated. Completely insane, but that's how it was done. And this madness of investment that were done on the basis of faulty assumption, I then discovered that it was the routine way that fisheries project, ports, and investment were done on a large scale. And I also realized that in tropical developing countries, the investment or the decision about massive investment in fisheries and science had absolutely no relationship. Absolutely no relationship. It was done by finance ministers, by premier ministers, by ministers of fisheries, and it went, for example, the fisheries minister of India would go to Norway and would be told that they got to fish, that there's fish in 500-meter depth, and they would buy giant boats. But in India, in 500-meter depth, all you have is oxygen-free water around India. And the boat then that India has bought fish on the shelf and compete against the small scale fishing. And that model I found everywhere. Absolutely no relationship between science and fisheries management. And I realized that really doing science that way and trying to develop methods so stock assessment could be made was actually a waste of time. And this is a time when I came, following a crisis, I came to Canada, and I was confronted in a country that at the time had a reputation of doing the best research in the world, the best fisheries research in the world. The Canadians were in hockey and fisheries management way up. And then what happened is the cord was lost. And the fisheries management was discovered to be largely not a fraud, but a smokescreen that was thrown in face of political maneuvering and ministerial discretion that you mentioned this morning, and that ministerial discretion could always overrule the science. So I found a situation that was similar to that in developing countries, a break between science and policy making. And I realized that reasonable policy making could be done only by another social force, that is the community of NGOs, environment NGO. And I went deliberately, explicitly to environment NGO. And I remember I went in 95 or 94 to a conference, and there were some people that were big, became quite big in the NGO community. They were huddled in a corner. The fishery scientists were all over the place, and they were huddled in the corner talking to each other. And I said, yeah, I'm Daniel Polly, I'm a fishery scientist, I would like to work with you. And for you in a sense. And they were wondering about this, and they wanted me to sign things and to go, because the NGO community is always has a burning issue, one at a time, right? And they wanted to use me for this burning issue and that burning issue. They said, no, I would like to do strategic research, stuff you need, but you don't know you need. And that was really what the Surrounders was. I wrote in the period between 94, when I began working here, and 97, I wrote a few papers that were successful. One of them was in Nature and stuff. And so I was invited by Pew, and the story is well known. Pew asked 5 or 6 scientists at the time what they should do, what they would do if they had a little bit of quite a bit of money, and to assess the health of the ocean. And they became a big discussion that you cannot assess, you cannot define the health. And anyway, if you were to do that, we would need 20 years of data with all kinds of electronics and submarines and stuff. And I proposed that the FAO data could be used instead, because the fisheries of the world could be seen as a gigantic sampling program. And I carried the day that became the Surrounders. And the Surrounders allowed me to deal with another issue, which is that there is a gradient of research, of access to knowledge that goes from rich to poor. And I had from the 60s and 70s a strong emphasis on the developing world. And while I could not continue to work exclusively on developing countries, I could work globally. And globally at least allows you to work on the developing countries and developed countries. And in a process of working on global issues, we evolved, and William, who is here, and Rashid, who is not here, a new definition of global, because usually a global program, and many of them originate in the US. In Europe, they don't dare to have a global program, but it's a US institution or two, one Brit and one Indian postdoc or Chinese postdoc, and that's global. And many of these programs, global this and global that, are not global at all. They are stories that are declared to be case studies, and whether or not they are representative of the world is not investigated. And you will see from one of my students later outrageous pictures of a global study which is not global at all. So we kind of redefine global as doing everything for the whole world or not doing it at all. And that has become a criterion. We do things in the Surrounders for all countries, or we don't catch it. If something cannot be done for all countries, then we don't do it. Because it would, if we did it, it would capture all our energy to do in depth in one place or the other, but we wouldn't replicate it in another place. This is, by the way, a principle also for fish base. We don't do a table, just an aspect of the biology of fish that we cannot do for at least 100 others. That's the reason why we don't have DNA studies in fish base, because not 100 fish have been done. So, the global thing, and the emphasis on NGO then is because it's not only because they are there and they need data, but because they don't get out of the regulatory agencies and out of the academic research, the research that they need. Basically, academic research is done as a follow-up to questions that are internal to a discipline. You have a discipline that poses itself a problem, and then it finds an answer to that problem, which causes another problem to emerge, and so on. So academic research is a good thing, is an excellent thing, but it is not applied necessarily. On the other hand, the research that, for example, the regulatory agencies such as NOAA, very good one, or DFO, or IFRAMER in France and so on do, it's research that is oriented toward the tactical, next year's quota. And in fact, 80% of the world, that is my guess, 80% of fishery science is tacticalness for next year's quota. And obviously the NGO community doesn't need to challenge the DFOs of the world on next year's quota. Rather, it's a question, should we have a quota system? In other words, the NGO community should ask meta questions, should not ask what the quota should be, but should we have a quota system, or what kind of quota system? And for research of that kind, there was no such research was being done. And I guess I was prepared to ask this question about what kind of research that the civil society needs, because at ICLAM, where I worked before with Rainer, and we had made the difference between strategic and tactical research. Strategic, and somehow they had no other. Strategic research was, I guess, with rice, they made the difference between taking a cultivar to the next step and working on the vulnerability of rice, I guess. But they made the difference between tactical and strategic research. And they also, I was also influenced very strongly by the West Research Institute and other big institutes, because they all had global databases. So if you want to know about rice, if you want to, NOAA has a database on rice, Rome, the World Food Program, has a database on rice, and I'm sure the Thai or French exporters have databases on rice production in the world. But fish, there was only FAO. So we tackled fisheries catch data. Why so? Because obviously catch is the most important thing in the world for fisheries. If you don't know the catch, you will not know a fishery. And this is being challenged by Airborne Company, because they say that what you need to know is the fishing mortality and stuff, but actually you need to know the catch of a country. And that's what the first thing that we did. We grabbed the FAO catches and spatialized them, so we can see them. We can see what the catch is. And that spatializing of the catch was important because catches are taken from ecosystems which occur in space. So catches should not be in tables. Tables of catch don't tell you anything about the real world. They should be in space. And then the catch should be the people who do tactical research always need to know the catch by species, by year, by age group. But we also want to catch by use. Do you want to use this catch for fish meal, or is it live fish, or is it used for human consumption, or is it discarded? That we now offer. Catch by gear. Do you want? Very often we are asked how much of the catch is caught, of the world catch or the continental catch, the catch of a continent is by gear. By which gear? By trawler, by purse seiners and so on. And that was not available. We have recently, with the help of Tim Chasham, with him, this young man who was there, and we have produced a catch by use and by gear of the world, and obviously by country and stuff. And we have, a few years ago, we have started working on a huge effort database, which Deng showed me we now have the design for showing this data. The effort database that will present the number of votes. Again, this is big tables in the UN, various UN organizations, but they are inconsistent, they are messy. We have made them less messy, and we are showing effort in number of votes, obviously, by length class, and you can turn length classes into engine power, because a certain length requires a certain engine, and then the contrary to length, we can add engine power. So we can express the total cumulative power of engines, and from that you can also compute catch per effort for all countries by type of fisheries. And you can also, from that effort, you can compute the CO2 emissions, and we have a paper that in marine policy about that. And then, because we have the catch of this major species in the world, and because we have Rainer Fröse, who has cleaned up these assessment techniques. Actually, they existed a long time ago, this kind of assessment, but the power of a powerful computer combined with the Monte Carlo method allows the stock assessment to be made from catch, essentially. And then if you have clean-up catches, such as what we have, you can assess all stocks of the world. And so last year, while I was having a good time in Hong Kong, relaxing in the palm trees, he's from Hong Kong, he knows that there's no palm trees. Deng and a group run 2,000 stock assessment for the entire world, and these are available as PDF, but as we speak, they are being transformed into interactive displays that people can download from the data for and rerun and so on. So the issue of we don't know what is happening to our countries is actually we can, not only is it not true, but here are the data for everybody to use. And we have been, 2 weeks ago, we have been in China. Deng and I and our colleagues here from China, we have run a workshop on applying some of this method. And because China does not have good catches, we apply them to length frequency data, and it works. And all of this is going to be on our website. And it seems to be that we are succeeding in empowering folks and making data available. So just as Rainer said, people will have no excuse if they don't do things. And I have spent the first month of this year on this report. The report don't get you any credit, but I don't need any at this point. And I would like you to grab these things and look at page 3 for the first thing that we did that was a big success was, scary as hell, was Billy Christensen, at the time with us, did the 3 maps of before and after, and that showed the high trophic level fish in the North Atlantic. And it looked like there is no more fish, but it's only high trophic level fish having declined by a factor of 10. And this is what people find, that high trophic level fish have declined by a factor of 10. And on page 5 you see really what really got us on the map is the first picture shows the open points, the official statistics from China at the time in the early 2000s. And you see how regularly they were going up. And they were so crazy that the government of China said that cannot be. That cannot be. And we are going to stabilize the catch. We moved from quantity to quality. And the catch miraculously went flat. This is a mockery. And in reality, FAO gave us a contract to re-evaluate the catch. We re-evaluated it. And what it led to is FAO had to present the catch separately for China and the world. And this is a result of a huge scandal that happened because FAO was criticized by The Economist, the magazine. And FAO's funding is always a tricky affair. Mainly it's the Scandinavian countries that fund FAO. And the funding is always tricky. And they were all of a sudden afraid that their funding would be cut because of the stupid article. And it led to an incredible story. I would like, and I have discussed this story in another book called 5 Easy Pieces. The other stories in this book, I have 2 more, but basically I've chosen here for this report 2 stories per year, 1 main story and 1 box with another story. And it's a report. Reports are usually boring. Actually, it's fun. Thank you very much.
Okay, it's never easy to talk after Daniel, so get used to it. This is the only photo I'm going to show you. Then there's another photo right at the end. The rest are really boring white slides. I want to take you on, give you just a brief summary on the latest Sea Rounders adventure in Australia. As has already been mentioned, I've basically been working with Sea Rounders since the very first year. I wasn't here on the 28th of June because I was delayed, stuck in Australia because my visa hadn't come through to come and join the Sea Rounders. And that was because the processing officer in the Canadian Embassy in Sydney had gone on maternity leave and they put no one in her place to replace her. So her inbox was growing, and no one was processing the visas. I ended up having to hire a lawyer in Toronto for $5,000 to write 1 letter that he faxed to the embassy in Sydney to threaten them with a lawsuit. And bingo, the next day I had a courier package with my visa. But that cost me $5,000. So if you want to change track, become a lawyer because you're going to learn really good. So in 2016, there was a really good opportunity that happened for us at the University of Western Australia, because they, Jessica has already indicated, she already told you some of this stuff, they went through a restructuring and a realignment. They sacked 200 people at the university, half of which were professors, the other half were support staff, and that caused all sorts of ramifications. But it was an opening, and Jessica, being as clever as she is, took that opportunity, and they actually created a new position. So 200 were gone, in exchange I went there. So it's kind of a trade-off. So I replaced 200 people. Right? My workload looks like that a little bit. Now, the University of Western Australia is part of what's called the group of 8 universities in Australia. It's part of the top 8 universities in Australia. And it is also in the top 100 globally, depending on which organization you look at. Sometimes it's ranked 98, sometimes 116. It doesn't really matter, but it's sort of in that area. As part of their restructuring, however, and it was one of the main selling points for getting a new position, was that they want to increase their international profile. And they also want to expand out more into Indian Ocean basin work. And, you know, that's basically what we do, right? We do big things, large-scale work. So, mid-2017, I packed my bags and I moved to Australia to form the first local branch, Siranga's Indian Ocean. You might ask, why do we want one of those? And I always try to explain it in this way. In terms of fisheries science, historically, the focus has always been on Atlantic fisheries or Pacific fisheries. And just think of all the examples that are being raised. Daniel mentioned the North Atlantic cod, or you hear about Atlantic bluefin tuna, or Hilborn talks about, oh, fisheries are doing really well, just look at Alaska pollock. So the species that pop out whenever people talk about it are usually Atlantic Pacific species. And the Indian Ocean has always been a little bit neglected on that. They, on the other hand, the Indian Ocean is home, the basin is home to about 1/3 of the world population. And, as we now know from the China, what is it called, the Silk Belt? Whatever. It's a major transportation highway, so the Indian Ocean is important for shipping and for all sorts of other issues. In terms of the fisheries, the large-scale tuna fisheries does receive some scientific and policy attention, but they have an equity issue, because there is a predominance of many distant water fishing fleets that play a role in tuna fisheries, but they're actually not Indian Ocean countries. And on the other hand, the fisheries that is really crucial for Indian Ocean countries are the small-scale fisheries, because they feed people and they provide livelihoods. But they are underrepresented in the general fisheries discussion and fisheries policy consideration. And they also have a massive data gap problem, which again, is where Siranga's comes in, right? We've talked about catchment constructions. So that was the birth. Now let's talk a little bit about the growth over the last 2 years. As I mentioned, University of Western Australia is Group A, top 100. But if you look at it in an Indian Ocean context, it's actually the only, globally speaking, the only top 100 university in the Indian Ocean basin. There is quite a bit of marine research going on at the University of Western Australia. They have an Oceans Institute, they have the Australian Institute of Marine Science as a branch there, CSIRO, which is the federal government's research branch, is there. But all of that research is based and focuses on West Australia. They have a lot of, in terms of marine engineering, they have a very high expertise level and recognized expertise because of oil and gas exploration. But very little of that research actually is Indian Ocean, it's West Australia. So, when the university turned around and said, oh, we want to increase our exposure to the Indian Ocean to a large-scale thing, that's what we do. Okay, so it was a nice institutional fit there as well. And when I got there, what was really nice is this. And it continues to this day. I have very strong support, and Siranga's has very strong support with the dean, and all the way up to the deputy vice chancellor of research. That is because we go out and do media work when we publish an important paper. I'm always surprised at what response I get from the university when we publish a paper and we write, Valentina writes a media brief, and I send it on up the chain, and they all say, oh, thank you, we didn't know this, because many scientists in Australia and the UWA don't do that. They just publish papers. They don't translate that into a message. They can't go out to journalists, to media, and therefore inform civil society. And we do that. So, the growth, I try to build partnerships as I try to grow the lab there. And Jessica's already talked about Marine Futures Lab. Jessica and I work together quite a lot in terms of thinking and strategizing, and also research and supervision of students. There's also the Oceans Institute, which is basically a hub where most marine scientists at UWA come together and try to network, and I'm increasingly active in that. And I've also joined the Africa Research Engagement Center at UWA, which mainly looks at policy and in the business school at the university, but it's hopefully an increased link to African countries. More externally, I'm building a relationship with Murdoch University, which is also in Perth, in particular with Professor Loneragen, who is actually very much interested in some of the oxygen work that Daniel, oxygen limitation theory that Daniel puts up, has proposed and is working on, and he's trying to employ some students, put some students on that. And also the West Australian Department of Fisheries, which I think just recently changed its name to something really, really long, so I don't use it. Because that's a funny one. When we did the catch reconstruction for Australia, every state department, Australian fisheries are generally managed by the states, and a few of them are managed federally. Every fisheries department in every state was happy to collaborate with us, share the data, provide the data, and help us, and even co-author the report, except them. They wrote us, or wrote Daniel, I think, a very, very nice email that says, oh, you can get information from our annual reports, which basically give you 1 or 2 summary numbers and nothing else. But we don't share data, particularly not with people like you. Okay. So I made it my mission to try to see what was going on when I got there. As it turned out, we actually sent our data request to the one person in the whole department who held a lot of power, which we thought would be the right thing to go, right? You go to the top and you ask for permission, who really didn't like us. Whereas all the people below him who actually dealt with the data wanted to work with us, but they didn't even know the query came in. So now that person thankfully has been promoted up sideways, hopefully out of the way. So I'm building deeper links to the department there, including us getting now, for the first time, actually the data from Western Australia on fisheries. Of course, as usually, not getting that data never stops us, right? We just went ahead and we found another way of estimating it. I'm also trying throughout the Indian Ocean to start building partnerships. The first one is with the Central Marine Fisheries Research Institute in India. The groundwork for that was laid by Deng and Reiner when they held their CMSY workshop there in 2017, I think it was. And I'm now in discussions with one of their directors to try to formalize it a little bit more to get a partnership, a relationship going on catch data. And it's going to be quite interesting because the director has a very firm view that they're actually capturing in their statistics all the catches of India. So it'll be interesting to see how this develops. This one is the most recent. There is a new project that started called FIDEA, Fishing Data East Africa, which is runs out of the Leibniz Institute in Bremen, Matthias Wolf, who I think you know. And it's supported by GIZ, which is German Organization for International Development. And they partner with the fisheries departments in Mozambique and in Tanzania. And they increasingly also want to include Kenya and Madagascar, so most of the big East African countries. And it is about improving data from small-scale fisheries. Across the board in terms of improving not just the data collection, but also the reporting and the use of the data, the analysis of it, and its transmission into, hopefully, into policy. And again, gap filling, catch reconstructions, that's where Sea Rounders comes in. So I've made the first moves to try to partner with them, because obviously we want to improve the catch reconstructions for all of these countries. So I'm very, very hopeful that this will also lead in future to workshops opportunity and capacity enhancing, because what they really want is they want to start owning the catch reconstruction process. And that's what we want. We want countries to own this because it's their data. Right? I recently talked with one of the deputy directors from the Kenyan Fisheries Marine Research Institute, and she said, we've been aware about the catch reconstructions for Kenya for a long time. We use it internally for policy and for discussions. There are some issues with it, and we wish they would be addressed, to which I immediately answered, tell us, because we want to fix them. And they said, oh, great. But then she said, what we really want is to be able to do it ourselves. I said, yeah, of course, because that's what we want. We want to be able to do it in country, so we don't have to do it. Right? It saves us some work, and you own the data, you own the process, you get better data, you get better products. So I'm very hopeful that this over the coming years will actually help East Africa, both help us, but especially help them. And in terms of growth, other than that, we continued our process of writing papers. There's a few of them. This was purely based on sea rounders data. This combined Global Fishing Watch over there. And this was one of the first products with the Minderoo Foundation to link fisheries and modern slavery. Talk about the Minderoo Foundation. It's a Perth-based philanthropic foundation, the owner of which has just launched last year the Flourishing Oceans Initiative, which is, I think, a $100 million initiative to address a few issues that is important to the owner about the oceans. One of which is that we will be doing with them a global fishing index. And other than that, that's my team. You know Jessica. Some of you might recognize this face here too. James Hare, he's also there. And you definitely know those two people, right? Lincoln and Rachel, both here from UBC originally. They now work with me. Thank you.
I'm going to talk to you about the relationship between fish-based sea life-based aquamaps and the sea around us, and how these four things work together. It started with Daniel Polly having a full box of index cards and asking what to do with these index cards, because they contain 175 life history data from after his work on the mortality in the 1980s. Then he met Reiner, and to click together, and that was like, boom, that's creation of FishBase. In 1989, FishBase was created with the help of the FAO, and it was created at the International Center for Living Aquatic Resources Management, which is now the World Fish Center. It then contained already the structure for trophic ecology, population dynamics, ecology, distribution, all hooked to the species as a unit of data. The milestones were, in the old days, we were doing it in CD-ROMs, and then we went to DVD-ROMs, and then we finally hit the internet in 1998, and in 2008, we had 30,000 species, or about 90% of all known species in the world, in FishBase. That was a big jump. And then in 2000, the FishBase Consortium was created with Sea Around Us as one of the founding organizations or institutions. At the time, there were how many? There were 5 institutions. I don't recall, but now there are 12 international institutions members of the FishBase Consortium. In 2015, I carried over. Daniel Reiner gave me the job of FishBase Consortium coordinator, so I'm now the FishBase Consortium coordinator, coordinating all of those 12 members worldwide. Now, in 1994, as we already know, Daniel came to the UBC, and then in 1999, Sea Around Us was born. And as a result of this FishBase Consortium, I came to join the Sea Around Us, so that fish-based data can be used in the Sea Around Us, and Sea Around Us results can then also be included in FishBase. That was my objective at the first time that I arrived at the Sea Around Us. That was the years, okay. And then Reiner also in 2000 left the Philippines to go to GMR and to work at GMR, and in 2004 recruited Kristen Kashner to create aquamaps. So in those days, there was only data from FishBase because Sea Life Base was not born yet. So milestones of aquamaps in 2005, it went online and provided aquamaps model for fish species, and now there are almost 25,000 species that includes fish and non-fish or aquatic organisms. That includes data from Sea Life Base. Back in UBC, the idea of a fish-based-like information system for non-fish species was created, and Nicola at the time was in between. We got married in 2003, so he was trying to come to Canada to join me, And Daniel gave him the idea, the job of creating a concept note, or writing the concept note for such a database. And we got funding for it in 2005 from the Oak Foundation. We got 5 years of funding for Sea Life Base in those days. So from 2005 to 2010, we had funding to build Sea Life Base. And I led it as the Sea Rounders person, and in collaboration with the fish-based team in the Philippines at that time. Milestones, right? 2008 went online in, Sea Life Base went online in 2008, and in 6 months we garnered 13,000 hits per month. And we thought, wow, we're doing it like fish base. So we were doing it right. And in 2010 we started thinking, okay, we cannot really, the job is too big. We cannot really cover 250,000 species worldwide of marine organisms worldwide. So we thought the best thing to do is go at it one marine ecosystem at a time, because you also have fish and you have the non-fish, right? So by doing the South China Sea as the first sort of go at it, we actually were able to do 50,000 species with the mandatory information that was necessary to build the database. So that's a good thing. Now with some support from the Global Oceans Legacy, we did consecutive marine ecosystems that were a part of the large marine, what is it called? Elamesia reserves network that they were trying to establish. So that's how you have the sort of like the network that is now created between fish-based, sea life-based, aquamaps, and now the four large databases work hand in hand, basically to give all of these products to the public. So there will be biodiversity, there's fisheries, and biodiversity is covered for all ecosystems. And like an example of the use of this thing is for providing this kind of data that is necessary to build ecopath models. And because we have predation, diet, food items, and ecology in fish-based and in sea life-based, so we can now make the data for a whole ecosystem available for modeling. And see around us then gives the catch data for the fisheries side of the ecosystem model, of the ecopath model. In 2014 to 2017, I was charged with providing the biodiversity part of sea around us, and that meant distribution maps or reviews of distribution maps by the sea life-based and fish-based team, as funding was coming from the Paul G. Allen Family Foundation for this, and we used FAO, IUCN, and the aquamaps, the data that we have in fish-based and sea life-based to, how do you say that, improve some of the mapping, and to use for our polygons for our own distribution maps. So that's how it worked. Between that time, actually, I was also embarking on doing the reconstructions for the Philippines, which was a long process, and which was what resulted in this report, which took me 2 years, and the Sea Life-based team, with the help of the Sea Life-based team, 2 years. This thing was 2 years in the making, and it was difficult, but it happened. And because of that expertise, now the Sea Life-based team has the capacity to learn the reconstruction for other countries. So in 2018, when the project that Dirk was talking about happened, they said, okay, we can engage the Sea Life-based team to help us with this. Okay? So now the contribution continues as it goes, because there's a very strong relationship between these three teams. This is now the team in the Philippines. Both fish-based and sea life-based teams and aquamap teams in this photo. You'll see that there's a a blonde girl over there. And this was a recent photo taken in June when Jessica and I went to the Philippines to finish some of the work that we were doing for Oceana on the CMSY. That's it, and so you can see.
Thanks very much. I started my experience with the Sierrangas when I first started my postdoctoral fellowship with Daniel in Sierrangas projects in 2007 for 2 years. I think that was one of my most academically stimulating years by working with Daniel and getting a lot of guidance in developing ideas and skills and way of thinking in science and other perspectives. I think that's a very important part of my career because basically lots of the things that I learned and developed in those 2 years form the foundation for building up my career in my subsequent years until now. And I'm going to highlight some of the main products, outputs, and things that we developed since then, and also through the collaborations after I left Sierrangas when I developed my own research. So it all, like many of the works that under Sierrangas, it all started when Daniel came to my cubicle and said that we should work on climate change. I have an idea. And so that's the time when climate change is still not a mainstream topic in fisheries. And at that time, you go to conference, and if you say that we should talk about, think about how to manage fisheries under climate change, people will thought, you're a bit crazy. That's not an important topic, but it's totally different now. Yeah, I think that's kind of highlights the how visionary at that time the Daniel would have on ideas, and this really highlight that aspect. And now we all know that the oceans are changing. Previous speaker already highlighted many aspects of that. We are getting a warmer ocean, more acidic, less oxygen. Sea level is rising. Sea ice is decreasing. And I think the key questions that we had at that time is that the Sierrangas has been trying to look at how much fish we remove from the oceans. But then the question is then how would climate change affect the future of fisheries? How would that affect how much fish we can still get in the oceans? We know that fishing will play a very important part. But we also know that the ocean is changing, and that's a big question mark of how that would affect future catches. And to do that, we first of all need to understand how the changing oceans are already affecting our current fisheries and productivity of the oceans, so that we can then use those information to make projections and develop scenarios for the future oceans and fisheries. So to start off with, we try to find out whether there's a relationship between observed catch and some of the biological and oceanographic variables in the global ocean. So what we did at the time as a start is that we look at the global catch data of the Sierrangas, and then we try to develop a statistical relationship and see whether the maximum catch that we've observed in each of the fish stocks around the world in the last 50 years is somehow correlated with productivity of the oceans, as well as the distribution of the fish stocks, because those are the things that, in theory, would affect the productivities of the fish stocks. And when we actually put all these data sets into the statistical model, we are actually really surprised to see that there's actually a really strong relationship between those, meaning that the oceans, how much fish we are getting from the oceans is really related to how much pine productions are producing from the oceans, as well as where the fish are distributed, because the fish needs to synthesize and obtain the pine productions from the area where they live. So that's provide us with a strong support and encouragement that by having this relationship, we would be able to develop projections and scenarios of how global fisheries may change under the changing ocean. And subsequently, there are additional works that are supported by CLR's data and built on these foundational work that we developed that further confirm that there is a strong relationship between oceanography that affects global fisheries catches and that interact with also fishing. And that different areas around the world actually are affected by different factors. For example, in area around Australia, because the area is a newly developed fishing area, it is really strongly affected by fishing, while compared to area like the North Sea, which has a long history of fishing development. Those areas are much stronger and heavily dependent on or are affected by oceanographic changes. And the second aspect of historical changes that we look at is that besides the overall productivities, we know that the different species will have different sensitivities on oceanographic conditions, particularly temperature. And so we want to investigate whether we are already seeing changes in the oceans, fisheries, in terms of their species composition and in relation to changing temperature. So we developed an index called the mean temperature of the catch. There's kind of parallels to the mean trophic level of catch that Daniel and colleagues have developed decades ago. So in this case, when the fish compositions in the fisheries catches are increasingly dominated by warmer water species, then the index of mean temperature of the catch increases. So what we find is that there's a strong relationship between the mean temperature of the catch and the ocean temperature, and that different areas will have different characteristics. Again, that provides us with a strong foundation that with global fisheries catch data, we are able to detect signatures of climate change on global fisheries catches, and that fisheries are already being affected by climate change. So now with these historical foundations, then we are able to make projections of the future based on the experience that we learned about how fish stocks and their productivities are affected by oceanographic conditions. And again, one day Daniel came to me and showed me and asked me to read a book called The Vast Machine. It was written by Paul Atlas. It was about the history of climate science. And he basically said that we should be able to do that for fisheries and the oceans. Basically, the idea is that we need to have a global data infrastructure combined with simulation modeling. And then with both of them doing together, we will then be able to make predictions and projections. And in the book, The Vast Machine, it talks about the predictions of climate or weather. But then in our case, it will be about projections of the changes in the oceans, biodiversity, and fisheries in the future. So we developed computer simulation model. We already have the data infrastructure from the Sea Awareness project. And we are then able to make projections of how global fish stocks are going to be distributed, how that would affect fisheries. This is one of the key, I think, signature paper that we published in 2009 that shows the global redistributions of fish stocks with increasing invasions in the high latitude regions and local extinctions along the tropical area. At that time, people still haven't realized that there will be global impacts of climate change on the oceans and fisheries. I think this really is one of the papers that bring people's attention to the topic. And subsequently, we use those projections to link it to colleagues in Princeton, University of Jose Sarmiento and his team to then develop future projections of how fish stocks productivities, particularly the maximum catch potential, will change in the future. And as you would expect, with the changes in the productivity and distribution of fish stocks, we project a large decrease in potential catch along the tropical ocean. And this map has been really influential. It's become one of the key figures in the summary for policymaker for the fifth assessment report of the IPCC. And building on that, I mean, some of my subsequent work then further developed that line of research and trying to, for example, highlight how would we gain or what are the benefits of keeping temperatures below 1.5 degrees Celsius, which is stipulated by the Paris Agreement. And then linking some of those projections to broader aspects of the societal issues in relation to sustainable development. And in this particular example, together with colleagues in Harvard, and Dirk is also in this paper too, that try to link the projected changes in catch with the nutritional securities of peoples in different countries, highlighting the high vulnerability of nutritional insecurity because of climate change in areas such as in West Africa and Asia Pacific and South Pacific region. So again, the ideas that we've developed over the years, I think there are lots of them, and it will require much more effort in order to follow that through, so that we can provide more scientific understanding and new finding to support the current need to find solutions to deal with the sustainable development under climate change. Particularly, we are working on focusing on developing scenarios for achieving ocean sustainable development, particularly looking at the biodiversity, climate, and food protections nexus. There's also increasing collaborations with colleagues working on terrestrial biodiversity and food protection systems, and linking the land sea systems together to get a more holistic view on these important questions. Building on the aquaculture database or mariculture database in the CRIS project, one of my students, Mohammed Olinda, has been working on the climate change impacts on mariculture. We are also looking at transboundary issues of how climate change are challenging transboundary fisheries. And one of the pet topics of Daniel is oxygen. And we have been working for years on how ocean deoxygenations are affecting fish, engaging with interesting debate with colleagues about that topic. And then lastly, we are really trying to move from just looking at impacts to trying to explore ocean-based solutions to deal with some of the problems that we have been highlighting in the last decade. So thank you very much.
Thank you. It's a real honor and a pleasure to be here. I have a severe allergy to microphones, so hopefully that won't show up. But I'm going to tell a little bit of a story about how I came to work on jellyfish and how I came to work with the sea around us. And I'll discuss a little bit about whether or not jellyfish are the seafood of the future, and if we might be serving jellyfish at, say, the 25th anniversary of the sea around us. So almost 20 years ago, in the year 2000, the first ever international conference on jellyfish blooms was held in Alabama. And they invited this man, some of you might know him, and his response was, "What the heck do I know about jellyfish?" And so he actually declined the invitation. But of course, we know that Daniel knows a thing or two about a thing or two, and part of the reason why they had invited him is because he had identified this trend of fishing down marine food webs, where we really are altering ecosystems to favor smaller pelagic fish as well as invertebrates. And part of this included jellyfish. And Daniel was being a little bit glib at the time when he said, you know, our grandchildren will be eating jellyfish burgers and plankton stew, but it looks like that prediction is actually coming more true than probably even he would have realized. And this quote was picked up quite a bit in the media. Jellyfish have historically been ignored, and by proxy, so have jellyfish scientists. And so I think they were quite shocked and thankful to Daniel for actually raising their profile. And so they tried again 7 years later. This time in Australia, they invited Daniel to come and speak at the Jellyfish Symposium, and this time he accepted and gave the keynote. And a couple of really interesting papers came out of that work. One showing how jellyfish have historically been ignored, both in online databases as well as ecosystem models. And he also worked with Deng to demonstrate that we can use tools from our traditional fisheries science toolkit to apply to jellyfish. We've done more work on that, and you know, jellyfish are unique in many ways, but we have a lot of tools that can be applied to jellyfish that are not really being employed. But one thing Daniel noticed while he was at the second Jellyfish Symposium was there was a conversation going on in the hallways and around the lunch tables amongst all these so-called jellyfish experts, and that was this question, are jellyfish blooms increasing globally? You say the word globally, Daniel Pauly pays attention, and so he did what any good quality scientist does. He says, I know how to answer that question, get a student to do it. It was just about that time that I was angling to become his student, and so fate would have it that he sent me to work on this project, which took several years. But these are the results of a study we published in 2012, which is the first ever global analysis of changing jellyfish populations. The black circles show all the data we were able to find of jellyfish populations over time, and the colors show by large marine ecosystem what sort of trend in the jellyfish populations we found, with red and orange being increases, and green being no obvious trend, and blue being decreases. And one thing you can tell from the map right away is there's a lot more red and orange than any other color. Another thing is if you notice all the red areas are disparate locations all around the world. So this is not just one localized place where we're seeing an increase in jellyfish, but it's many, many ecosystems around the world. We're working on updating this study, and I expect there may be some changes of a few regions, including the Mediterranean, which is being hit even more and more by jellyfish blooms, which Kiara can probably attest to. But working with Daniel, of course, my attention shifted towards fisheries, and I was somewhat surprised to learn that people ate jellyfish. And as I dug into it, I learned that people actually eat a lot of jellyfish. Most of the consumption and the fisheries are in Asia. But it's rare that you would go to a wedding or a banquet in China where they wouldn't serve jellyfish. And so I started to dig into the numbers and look at the fisheries, and they're quite large. We have traditional fisheries like in China and Myanmar, where they've been catching jellyfish for decades, if not centuries. And there's new fisheries emerging in places like Mexico and the United States. And digging into the FAO data, you know, if you thought statistics were bad for finfish, well, they're even worse for invertebrates and especially zooplankton. But the FAO catch shown here shows that catch landings in recent decades fluctuated between about 200 and 400,000 tons, which is fairly significant. But using the methods developed by the Sea Around Us, I performed a catch reconstruction for jellyfish catch globally. And as you can see, even just in China, they're catching more than what is reported by FAO for the entire globe. If we include the other countries, we can see that in recent years, jellyfish catches have absolutely shot up and have gone over 1 million tons of catch. If we put this in context, we average over the last 10 years, we can see that jellyfish catches are averaging close to 750,000 tons. To compare that to some other seafoods, the global catch of jellyfish is higher than it is for things like lobsters and mussels. So all the mule frites we add in the world isn't even half of the jellyfish that is eaten. People often talk about krill fisheries as being the largest zooplankton fishery in the world, but jellyfish are more than triple the amount of krill that's being caught. So in that provocative title, Are Jellyfish the Seafood of the Future? I would suggest they're actually already the seafood of the present, because we're eating a lot more of them than many other groups. And these fisheries are expanding all around the world. They're still mostly focused in Asia and Southeast Asia. However, there are new fisheries cropping up, as I mentioned, in North America. There's also test fisheries in Europe and Central America and South America. We've even tried fishing them here in Canada, which wasn't really successful because of the kind of species that we have. So people often think, okay, well, if jellyfish are increasing, then we can just eat our way out of this problem. We're pretty good at overfishing, right? But there's a whole bunch of reasons why that's probably not a real solution, where there's only a handful of species that people really like to eat. As well, you know, there are people that are involved in jellyfish fisheries that want to create a sustainable fishery, and so they're not looking to overfish the resource. In fact, in China, where jellyfish catches have been declining, they now have hatcheries where they release millions of baby jellyfish into the ocean, hoping that they'll increase their catches. So There have been several other jellyfish symposia since. Daniel and I presented our work in Argentina, actually with a little bit of help from Philippe Curie right before we went. I've also presented our work at the Force Symposium in Japan, as well a few years ago in Barcelona. And later this year, in 2019, is going to be the 6th International Jellyfish Symposium to be held in Cape Town, South Africa. And I'm actually on the Scientific Steering Committee, so my work with Daniel and the Sea Around Us on jellyfish has really come full circle with respect to the Jellyfish Symposia. And many of us are really excited to head to South Africa because I don't know if you noticed on the map of increasing jellyfish populations, but nearby South Africa off the coast of Namibia in the Benguela current ecosystem is one of these regions where it appears to have switched from being an ecosystem that was dominated by fish to one that is now dominated by jellyfish, in terms of it's now an alternate stable state where even though the fisheries have collapsed and they've reduced their pressure, the jellyfish are eating the fish eggs and the fish larvae, and the fish populations now won't recover. So we have this alternate stable state of now jellyfish dominating the ecosystem. So in the past, if you had gone there, you would have seen hugely productive fisheries. Now if you go there, this might be the sort of scene that you see. And these are not small jellyfish. This species can grow up to 20 centimeters in bell diameter. So you see these massive blooms of jellyfish occurring in this region. And this is potentially a glimpse of what some of our future oceans might look like, as many human activities have been linked to increasing jellyfish populations. So stay tuned if we're going to serve jellyfish at the next Sea Around Us anniversary. I, for one, hope not, but if we do, I'll keep collecting those recipes. Thank you.
Okay, we have talked a lot about Sea Around Us data, and I think a lot about the ideas that are driving this data collection. And I, for one, thought you stand on the shoulders of giants. You also live in their shadow. It's a very big shadow. And so when you leave, you should try to, break out and do something on your own. And then you find you can't, because the Sea Around Us data is all around us. So I teach marine ecology and conservation. I use Sea Around Us data every semester in almost every class. If I'm talking about the number of marine protected areas, if I'm talking about fisheries subsidies, of course, if I'm talking about global catch or aquaculture, anything really that I teach in that class comes from the Sea Around Us, so I am completely embedded. And I am a meme then of this project out in the world, and we just have to admit that. And I think it's really great. One thing that's struck me throughout the day is how much we all are willing to admit that, right? That we are part of this bigger thing that has been led by one individual, but is by no means one single individual. And anyway, we'll talk about a little bit more the strategy, and of course, I think the values that are driving this research are the most compelling thing of all. So I also did my PhD with the Sea Around Us project. There we all were at some point, there will be a photo from this event. You just keep getting photographed at Sea Around Us events. And then, like a lamprey, I clung to the project for 3 years as a postdoc. And then I got this faculty job at NYU. And those were better times before I wound up back at NYU. And there was a period where even Daniel was filled with optimism. And now we live, of course, in this new era. But it's hard not to go back. I got my PhD 10 years ago here in 2009. It's hard not to go back to moments like these and remember, how much we felt like things could change. And this moment may happen again, let's hope. And then we'll have a different context for the next, maybe the 25th or the 30th anniversary. And one of the things that I have my eye on that's giving me a little bit of hope, but also, of course, filled with trepidation, is the BBNJ negotiations. So the Biodiversity Beyond National Jurisdiction negotiations that are occurring right now at the UN about whether or not we need a new treaty to protect the high seas. Now, in 2014, Greenpeace approached me. I have collaborated with them regularly. Very much like Daniel, I'm in favor of working with any civil society groups that share my personal values. And they said, do you want to bring your students up to the United Nations? And I was just new faculty at NYU, and I said, yeah, sure, that sounds good. What do you want? And they're like, we want them to stand outside, and we want them to ask if they will have a meeting to decide whether or not to have a meeting, to decide whether or not to protect perhaps part of the high seas. And I was like, that sounds pretty, low key, and I'm not going to probably lose my tenure track position over something like that. And so these are my students. They're wearing, as you can see, a jellyfish burger around their neck, which was one of my many weird projects as a student, was to make an image of some of Daniel's ideas. And they were wearing it around his neck, and we were asking the people going into the United Nations at the time, please have a meeting, in which you say we will have a meeting to perhaps negotiate a treaty. And now that is what happened last year. So that was 2014. In 2018, the treaty negotiations began, and they will end or be extended as of spring 2020. And that's important for a number of reasons, and one of the reasons that I think is useful today is to talk about the way in which the Sea Around Us data is being used at BB&J. So we're in the midst of these, what is called biodiversity beyond national jurisdiction, and one thing that makes me a little nervous is the use of sustainable use in the title. But anyway, in advance of this meeting, I'm now also an editor at Science Advances. We decided to do a special issue on the science of the high seas and then deliver it to the United Nations in September of 2018. So that, and this grows right out of the values, again, that are embedded in the Sea Around Us project to do science that is relevant to policy. So we had a call for articles that were related to science on the high seas, and we managed to get this print issue out and up at the United Nations, and every single one of these articles touched on one of the issues that were being negotiated at BB&J. I had to wheel these really heavy journals up to the United Nations and got them on the desk of every negotiator there. The paper that I contributed to in that special issue was a direct, let's say, defensive strategy toward an argument that was being made by some people, including those at the University of Washington, saying we couldn't possibly close the high seas to fishing or even really restrict high seas fisheries because they contribute so much to global food security. And so what we did, working with a team with Lauren Schiller, who was Daniel's master's student, now working with Megan Bailey, who was Rashid's PhD student, and then Enrique Sala, who's a longtime ally of Daniel's. The four of us worked together using the Sea Around Us data, as well as a couple other data sets, to show actually that high seas fisheries contribute a very negligible amount to global food security. They contribute less than 2.5% of total seafood production, and there is in fact 39 species that represent 99% of the catch from the high seas. Only one of those, Antarctic toothfish, is fished exclusively on the high seas, meaning that if you were to close the high seas entirely to fishing, you would lose that one fishery, and you could still have fisheries for every single other species within EEZs. And this is something that we were only able to do because of the spatial allocation through the Sea Around Us data. And it was I think, an important argument to be made at the right time, so that you could not have industry saying this will hurt global food security if we touch fisheries at all. Now, some countries are still arguing fisheries should be off the table there. And then the Sea Around Us project, and of course Rashid will talk a little bit about the economics and the spin-off from the Sea Around Us, but has been very important for noting that high sea fisheries may be small in terms of global catch, but that they're very valuable to some countries and arguably to some industries. And so some of the work I'm doing right now is also relying fundamentally on Sea Around Us data, because I've said, well, what we've done with climate change is we've been talking a lot about responsibility for emissions by country. And what's been interesting to watch in the climate change world is how we've extended responsibility in all directions, of course to individuals, but also to corporations. And I thought we could do this for especially high seas fisheries. So just as we've done that for global emissions, where we say Chevron or Exxon Mobil represent X% of historic emissions. We're trying to do that for the high seas now using Global Fishing Watch data, which we can get every single boat on the high seas from that data set anyway. And then we've assigned corporate actors to about 2/3 of that data set. And then we can use the catch data and allocation that's already been done in another issue in that journal actually, which Rashid and Daniel were, or at least Rashid was part of the economics paper, you were as well. And we can use that data to overlay onto the vessels so that we can say not only which corporations are fishing the most, but what they're catching, and even an estimate of the subsidy that they're getting in various ways. And so this is another way in which the catch data of the sea around us and then other estimates are being combined with this real-time empirical satellite data. I think Jessica mentioned that kind of strategy as well. So these are really early heat maps. This was for the China National Fisheries Corporation. I've been carrying out this work with another way in which Daniel has influenced me is like there's nobody you should overlook in terms of free help or very very small payments in my case to undergrads. And I have teams of undergrads working on this project. And benevolence goes a long way, is what I've learned from Daniel. So she's put together actually these heat maps and done a lot of the work on corporate assignment, and now she'll start a PhD at Duke. And then this is Dong Wang, but as you can see, what we're able to show is fishing effort by corporation on the high sea rather than just by country. So again, our work, the next step, which is occurring this summer, is combining that corporate data with this profitability model work that was done last year, so that we can talk about profitability by corporation. And then I just want to mention briefly other work that Daniel did that was really important. Daniel and Sarika Suzuki on RFMO performance in terms of stock management. And we've taken that method that they used in terms of scoring RFMOs by a variety of criteria. We applied it to transshipment policies by RFMO. We have a new paper that's doing that in terms of fishery observer protection and coverage in general for compliance. And then we're going to do a large-scale RFMO performance evaluation that will include the stock data, status data, but also as well as some of these other sociological factors. So again, just the influence of sea around us that you just can't avoid, no matter how hard I try. And so, Daniel had already had the idea of adapting this model and applying it to RFMO stock management initially, and then we've taken that and modified it. This is how science works. And one thing I just wanted to mention, of my own, toot my own horn, is that just very occasionally, almost never, but the influence runs the other way. And I got Daniel to mention the fact that in this very strange paper Daniel wrote praising, and Dirk wrote praising the FAO, which is, we know not always the case. He did actually also praise them for mentioning welfare, animal welfare, which was something I've been subtly and very explicitly pushing for a long time. And I wanted to mention we were assigned to say, okay, what could the future look like for the Sea Around Us project? What are the exciting new opportunities? And where I am in New York and at NYU, we have a new Center for Environmental and Animal Protection. There's actually a lot of philanthropy in animal protection in general, and I think we need to start thinking about aquatic animals as animals. And one of the ways I think that FishBase may be able to do this is incorporating some new data that's coming out. This group has just done this fish ethobase on all the welfare related literature to various species that are being farmed in terms of farmed fish welfare. And there are other projects I think that could very much align and feed into that. And then we love this graph, right? Love it, love it, love it. But I love this graph where we talk about, and you also have one of these printed, I think, on page 19 of the booklet you handed out. As a final remark, Daniel is often talking about this analogy of do we build some people build towers, and I build pyramids, and he's absolutely right in terms of that analogy, but he does downplay, and this is something that I've really come to appreciate more that I have my own faculty position and trying to support my own students. We really have to fully try to understand how personally arduous this has been for him, and how much the weight of having this amazing 400-person at times team, how much weight that can be on your shoulders. I think it's more Sisyphusian, what the adjective would be, task than he lets on, or in maybe a really good day, an ultra marathon. This is the only time you'll ever see Daniel running an ultra marathon. This has required an incredible amount of weight to carry, I think, on one person's shoulders, and of course shared among many people, but primarily, when the bills have to be paid, I think people look to Daniel. And it's not just that he works globally, it's that he works annually, which is nuts. Like, if you were like, yeah, global, that sounds good, it's like, no, but every year we will update this database. It's like, okay, now you're insane. Because you build these things and then you have to keep them running, and and you have to keep it funded. And I just really now am again starting to appreciate how much work that's been and how impressive it all is. So thanks.